Got something you want to share to the world? We got you, fam! We are looking for awesome people like you who want to share content that deserve a spotlight on our site. Whether it's a list of everything you love about catos and doggos, pop culture related artworks, or even your own random photos, memes, and funny videos, we'd be happy to see it and share it to the world. Join our award-winning team and be part of our Ink Pop creator community.
Hey, it's me, Guyito. Want to become a writer, artist, or photographer when you grow up? Test your creative skills with us. We're looking for kids aged 7 to 12 years old with unpublished work like articles, short stories, poems, essays, artworks, videos, and others. Join our award-winning team and be a part of our Kinderpop contributors and get your awesome work published for the entire world to see. Send in your work to pop@inquirer.net or visit facebook.com/inkpop to know more. Now let's show them how kids get it done.
kaso ng COVID-19 sa 1,074 provinces. 240
Convergence releases its COVID-19 update for July 12. Total cases here in the country are now at 56,259.
Got
Please stand by as we are about to start the National Mechanical Engineering Students Convergence. This event is brought to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit, Incorporated.
Our community partners, JPSME Ateneo de Davao University, JPSME Central Mindanao University Chapter, JPSME Eastern Visayas State University Tacloban Chapter,
JPSME Polytechnic University of the Philippines Alfonso Campus, JPSME Polytechnic University of the Philippines Taguig Branch, JPSME Xavier University Chapter,
JPSME Mindanao State University Iligan Institute of Technology, Unified JPSME Northern Mindanao, Mechanical Engineering Society, University of Perpetual Health System, Delta Calamba,
Mechanical Engineering Student Society, Batangas State University, New Era University Association of Mechanical Engineering Students, PSME Southern Luzon State University, PSME Bicol State College of Applied Sciences and Technology Student Unit,
PSME Bicol University Student Unit, PSME Camarines Norte State College Student Unit, PSME Lyceum of the Philippines University Cavite Student Council,
Manuel Tarlac State University Student Unit, UP Society of Geodetic Engineers,
PSME Mariners Polytechnic Colleges Foundation Legazpi, PSME Technological Institute of the Philippines Manila Student Unit, PSME Technological Institute of the Philippines Quezon City Student Unit,
PSME Manuel S. Enverga University Foundation Student Unit, PSME Mapua University Student Unit, PSME National University Student Unit, PSME University of Rizal System SU.
Special thanks to UP Beta Epsilon Fraternity.
Our media partners, Inquirer.net, Inkpop, SparkUp.
Some reminders for our audience. We have a charity drive entitled PSME Cares for Miss Dorothy Ancilio, who was diagnosed with acute lymphoblastic leukemia and passed away last August 20. John Roffer Aguilios, on the other hand, lost his father and two siblings during a fire incident. A donation drive was initiated to help their families in these difficult times. Any amount would be a great help for their families to pay for hospital and funeral bills. Monetary donations may be sent to the following on your screen.
There will be a raffle winner picked every day of NMESC. To join the raffle, simply answer the evaluation forms to be sent out by the end of the day for a chance to win 200 peso cash.
To those who wish to get their e-certificates, remember to answer the evaluation form at the end of the talk for your details.
If you have questions for the speakers, comment on the live stream with your full name /school/ your question, and it will be carried over to the speaker by our moderators.
Disclaimer: the views and the opinions of the guests and speakers do not necessarily represent those of the organizers and partners of this program.
On with the show.
Good evening, everyone, and welcome to the third day of this event. In celebration with the 14th PSME Month with the theme Linked, Connect the Nation, Assemble the Future, we hold the National Mechanical Engineering Students Convergence. For years, the NMESC has brought mechanical engineering students the opportunity to learn from professionals and experts in the different fields of mechanical engineering. It has also presented students with the knowledge of an ME's life in the industry through company talks. And yesterday, the one that we did is about engineer Glenn Espena, who worked with the Emerial project, and of course the Austria Vent 2, which is an adult ventilator, which actually sparked up a lot of questions among aspiring and existing students of mechanical engineering about how it worked and how a mechanical engineer can work in the medical field. But before we head on to the talk, we will be announcing the winner from yesterday's NMESC Daily Raffle promo. And the lucky winner for the 200 peso cash is Lorraine A. Estosane. Congratulations! You may now claim your prize by coordinating with the show's organizers.
Now, moving on, our speaker for the day has had a prolific career in the field of mechanical engineering for most of his professional career. Currently, he is an assistant professor in mechanical engineering at James Watt's School of Engineering in University of Glasgow, UK. He is also currently a professorial lecturer in the Department of Mechanical Engineering, University of the Philippines, Diliman.
He finished his bachelor's degree in mechanical engineering in St. Louis University. He then attained his master's degree in mechanical engineering with a major in engineering design in University of the Philippines, Diliman.
For his PhD, he studied engineering mechanics in the School of Mechanical and Aerospace Engineering in Nanyang Technological University, Singapore. In the same school, he was both a research fellow and a scholar.
Aside from his current job as an assistant professor in history as research fellows, he also spent time in the academe as a seasonal lecturer for the University of Newcastle, Singapore.
As for time in the private sector, he has also served as as one of a consultant for Principia Engineering and Technology Center and an associate principal R&D engineer in Vestas Technology R&D Singapore.
For the audience, you may leave questions in the streams during the speaker's talk. Please include your full name and school before stating your question.
Now let us give our warm welcome to Dr. Christian Della.
Good evening, everybody, and thank you very much to the PSME-UP Student Unit for organizing this event. Now I'm going to start with my presentation. So good evening, everyone. Welcome to my talk. The title of my talk is Mechanical Design Engineering in the Age of Industry 4.0. I'm Christian Della. I'm currently an assistant professor for the School of Engineering, University of Glasgow, UK, and I'm currently based in Singapore. At the same time, I'm also a professorial lecturer at the University of Philippines, Diliman, currently teaching machine design. Now, I'm really proud to be working in one of the top 100 universities in the world. This was established in 1451, meaning that this is the fourth oldest English-speaking universities in the world. It's associated with 7 Nobel laureates and also famous engineering personalities that we mechanical engineers know about. They are James Watt, Rankin, and Lord Kelvin. So I'm really very proud to be able to be working for this university. If I can do this, definitely you can also do this one or even better. Now, I'd like to start this presentation by showing you this picture, which is being used as the background for the 2021 7th International Conference on Mechanical Design Engineering. We don't see the gears that traditionally represents mechanical engineers. Well, we see robot hands trying to, whether it's drawing or manufacturing a digital automobile. So the question that we ask is mechanical engineering being forgotten, or is mechanical engineering just evolving? So what is Industry 4.0? So this is the talk is about the mechanical engineering or mechanical design engineering application in Industry 4.0. But before that, let's try to define Industry 4.0. Let's try to look at history first. So the first industry, or the Industry 1.0, is basically in the late 1800s. So we have this mechanical manufacturing to be powered by steam engine, very mechanical. I mean, based on our background, this is what we may call mechanical engineering, because it is really mechanical. All those heavy, huge stuff that was studied during our undergraduate study. The second is, of course, the improvement of the manufacturing through the concept of mass production and assembly lines that's powered by electricity. The third is the manufacturing automation through the use of computers and IT. And the fourth industrial revolution is about intelligent manufacturing, merging of real worlds and virtual worlds. From first to fourth industrial revolution, it's very obvious that we need to develop and improve the manufacturing systems and processes for continuous development. Now, are we really at this fourth industrial revolution era? Now, most Industry 4.0 initiatives are still at the early stage process with a limited scope. So this one, Industry 4.0, we hear a lot of Industry 4.0, but at the moment, they are just initiatives, very limited scope. And pretty much this Industry 4.0 efforts are based on still improving the third or even the second industrial revolution goals, still achieving those third and industrial revolutions and trying to use the current technology to improve those technologies. Now, the Boston Consulting Group identified 9 technologies transforming industrial production. These are the Internet of Things, robots, augmented reality, big data, 3D modeling, cloud computing, system integration, cybersecurity, and simulation, which will be the focus of my talk. So what are the key components of Industry 4.0 according to the American Society of Mechanical Engineers? These are the Internet of Things, which is connecting the networks, the big data analytics, which provides insights to many information out there. We have the simulation, which is about virtual prototyping and testing. And we have additive manufacturing that now provides the opportunity to fabricate or even manufacture complicated geometries. So when I speak of simulation, I speak of the finite element analysis, which has to deal with solids, and computational fluid dynamics, which by the name of itself talks about or discusses about the movement of the fluids, or simply fluid flows. So what is the future of mechanical engineering? There was this interview in 2008 in one of the conferences, and one of the students asked the professor, "What is the future of mechanical engineering?" So the answer, well, the future of mechanical engineering is not mechanical engineering. Okay. So we need to ask ourselves what we define as mechanical engineering, what we define it today, and what we should be defining it for the future. Then we can begin to talk about the future of mechanical engineering. So for this generation, your generation, are we looking at the rise of digital mechanical engineering? So what does ASME, or the American Society of Mechanical Engineers, describe, or how do they describe digital mechanical engineers, or simply digital engineers? ASME says that the digital engineer is now expected to carry out simulations in the virtual environment first before proceeding to the design, build, and test stages. In industry, this approach results in reduced product development cycles. So what about GE? What is modeling and simulation-based engineering to GE? We know that GE is one of the top companies in the world. It's a Fortune 500 company, and really it does a lot of innovative works. So to GE, modeling and simulation-based engineering is a critical enabler for product design. This one is an essential capability for solving problems with and improving the performance of complex mechanical systems. So modeling-based engineering, or modeling and simulation-based engineering, is used to optimize the design of parts and other equipment to understand environmental and situational effects on parts and products that can have significant impact on product performance, efficiency, and quality. Modeling and simulation-based engineering is critical to reducing product design time, improving part and product performance, and improving the manufacturability and serviceability of assets. What about Siemens? In Siemens, simulation-driven design is an essential part of the development process throughout concept and design. Simulation is leading manufacturers to discover and produce new designs, aided by new manufacturing processes such as additive manufacturing. Simulation helps designers create better, more robust designs earlier in the development process, while also speeding the overall time it takes to release a design, i.e., faster time to market. But just like mechanical engineering, simulation-based engineering is also evolving. Let's have a look. In the 1960s, simulation is just based on or being applied for specific individual applications, such as mechanics. In 1985, we see the development of simulation tools, which is why they are now able to answer specific design and engineering questions, such as fluid mechanics. In the year 2000, we see now simulation to have advanced to be able now to analyze the whole system. So simulation allows a systemic approach to a multi-level and multidisciplinary systems with enhanced range of applications. So what about digital twin? Digital twin now is a core functionality of systems by means of seamless assistance along the entire life cycle. Okay, still not clear to me. So let's try to define what is digital twin. Yes, let's start with a physical twin. So we know that we have this physical system, and we made a digital twin, a simulation model out of that physical twin. So from the physical twin, we can get performance data, health data, maintenance data, and also the events or loadings that can affect the physical twin. This information can be transferred to that digital twin, that virtual system model, where we can analyze the effects of events and actions. We can trace the history, and then from there be able to come up with some adjustments or recommendations, as well as preventive maintenance measures to the physical twin. So this is a simple concept of the digital twin. Digital twin basically is the seamless integration of Industry 4.0 technologies. As we can see, all these technologies are available. The current problem is trying to integrate them so that we will be able to increase production as well as increase the life of our engineering structures. There was a report in Europe that the digital twin market is expected to grow to over 15 billion by 2023. As mechanical engineers, we probably will be able to contribute in the CAD and 3D modeling as well as the simulation. Of course, again, depending on your major later, you probably will be able to touch some of the other specialties as a data analyst or maybe robotics or robotics engineers and so on. So moving forward, there are now many digital twin concepts that has been presented in the literature. We see them to be applied, or we see the potential application in the manufacturing, automotive industries, offshore, aerospace, and of course, wind energy. So where do we start? Let's start from the basics. Let's have a look at these two drawings here, and let's assume that the one on your left is the physical twin and the one on your right will be your digital twin. So from the physical twin, we will be able to extract information, and then we can transfer that to our digital twin. As mechanical engineers, we will be able to see the stress distributions within our components or structures. And from there, we will be able to come up with a conclusion whether this one is going to be safe or not. Or if this one is going to continue, how long will this last? This is a simple concept of the digital twin that we can start to learn. One of them is, of course, learning the finite element analysis. So in this case, this is just a simple static analysis where we study the stress distributions within our piston, connecting rod, and crankshaft, or basically just a single cylinder engine. Moving forward, we can also improve that model, make it transient, which is what digital twin wants to. So we can see here that we can apply the loads while it's moving and observe the stresses and deformation within our structure. From there, we will be able to determine whether our structure will be safe or not. That's our job as mechanical engineers. So what about if I'm working on fluids? This is a classic example of a CFD analysis or computational fluid dynamics analysis on a pico hydroelectric turbine. So as we can see, we are able to simulate the flow of water through our hydroelectric turbine, and from there transfer the information to our model or our finite element model, and be able to determine the stresses and deformations in our propeller. Thereby, we will be able to determine whether our turbine will be safe or not based on the loads that we have. Now, if we see that there is a high stresses in our a very high stress acting on our structure, then we probably can inform the operator to probably lessen the load that's being applied to our turbine. And that's how this one works. It's just that for digital twin, instead of human trying to inform the controller, it's now AI trying to inform another AI to control the operation of this turbine. So if I want to learn how to develop simulation models and probably become a simulation engineer, what do I need to know? What are the knowledge and skills that I need to develop? We are already mechanical engineers, so we probably would have already a strong background in our engineering sciences, or looking at mathematics, we're looking at physics, we're looking at engineering mechanics, heat transfer, thermodynamics, and so on and so forth. We should have a strong understanding on the theories of the computational model methods. It's not just application of tools. We see nowadays that there are many softwares being used by people who don't really know the physics behind, or the mathematics or the science behind these tools. And that's really dangerous because they might be designing something that's not safe or can cause some problems in the future. So it's really important to have at least a good understanding on the computational methods that we have at the moment, uh, what are their strengths and what are their limitations. So here, when I say computational methods, I'm specifically talking about the finite element analysis and computational fluid dynamics. We have been now familiar with the use of CAD tools. Um, so we see a lot of multinational companies investing in the Philippines, trying to hire engineers to develop CAD models for them, and that is good, of course, for employment. In terms of simulation, the availability of CAD tools enables a faster simulation or faster development of simulation models. It's also important to have an understanding on the use of the software. So aside from increasing our understanding on the mathematics and science of these computational methods, it's also good to understand how to operate the available commercial softwares, if not the free softwares that are available, because nowadays commercial softwares can be very expensive. So these are the four skills that we really need to develop uh, to be able to improve our skills and knowledge in simulation driven engineering. We have our background, the understanding of the computational methods, familiarity with CAD tools, as well as the familiarity of simulation softwares. So this is basically what we know. So if we're strong with this one, then it's good to move on to understand the different skills and knowledge, and of course, growth. Definitely, you have your knowledge in engineering materials, you have strong engineering mechanics, you have very strong heat transfer and fluid mechanics background, and I'm sure you have dynamics, kinematics of machines, and machine design knowledge. That's how we mechanical engineers are trained. In the design process, how do we apply simulation? So we know that in design, we need to identify the problems, identify solutions, we need to prototype, test, and evaluate, and improve the design. So the prototyping, testing, and evaluating and improving can be very expensive and time consuming. But through simulation, we will be able to reduce the cost as well as the time to be able to conduct various prototypes or develop prototypes, as well as virtual testing, while we are also improving the performance of the design. So let's look at this new concept, which is design thinking. So this design thinking is a method of designing a product that tries to understand the needs of the users. So this design thinking concept encourages us to work with the users to develop our design. So it starts with the empathize, understanding the needs of the users, defining the problem, coming up with idea, prototyping, and testing. Of course, this one is not linear. This process is basically non-linear. So where does simulation comes in the process of design thinking? Here, because prototyping and testing can be time consuming and very expensive, simulation can really play a major role. There is also that concept of iterative design, wherein you design, prototype, evaluate, and if you need improvement, then redesign again, and so on and so forth. So you do a lot of iteration. So getting it right the first time is hard, and the first design that you have probably won't be the design that you're going to release to the users. So here we will need better support for quick turnaround loop. So simulation becomes essential. So what about innovation? Just to quote Thomas Edison, if I find 10,000 ways something won't work, I haven't failed. I am not discouraged because every wrong attempt discarded is another step forward. Also, he mentioned that genius is 1% inspiration and 99% perspiration. In an article in Forbes titled Why the Future of Innovation is Simulation, it mentions that innovation is now 1% inspiration and 99% simulation. So innovation is about repeating things until you think you have perfected it. And with that, simulation really plays a very important role, making our repetition process to be faster and of course, cheaper. Why simulation? If it's not applicable to design, we can always use simulation for safety analysis, fire protection, heating, ventilation, air conditioning, power plant operation, and so on and so forth. Because as you can see from Murphy's Law, anything that can go wrong will go wrong. So if I'm not going to design with all this knowledge that I have in mechanical design engineering, where else can I apply my knowledge? Of course, there's that design for manufacturing, there's that mechatronics and robotics, there's that reliability, stress analysis, and failure prevention. Of course, our knowledge in mechanics is also very important here. We also have vibration analysis as well as plant operation and maintenance. Okay, so are we saying that we'll just focus on our technical skills? What do you think? In this case, we should also try to improve our soft skills. This is what it's being mentioned at the moment. In order to be job ready, or in order to survive the current industry, we need to be adaptable. We need to be willing to learn. Yeah, we have already completed your bachelor's degree. Should you be learning more? Of course, learning never ends. So of course, it's not just IQ. We also have to look at EQ. We have to develop our interpersonal and communication skills. We need to improve our problem-solving skills. And of course, we need to be creative. So engineering is not just about using the formulas, memorizing the formulas, passing the board exams. When this is over, you're just going to become an Excel spreadsheet to them. So you don't want to be that Excel spreadsheet trying to use those equations, putting in the numbers, coming up with the solutions to the problems. You probably would like to be the person who creates that Excel sheet. And is that possible as a mechanical engineer? Definitely it's possible. So yes, you have now the technical skills, you have now your soft skills. Let's talk about potential employment. So let's look at the main contributors to the Philippine economy. We have, of course, our Bagong Bayani, the OFWs. Of course, we also know that there are many engineers who are working overseas. We have the business process outsourcing. So what is more famous at the moment in the Philippines is the call center, and we have quite a number of engineering services outsourcing already. We have construction, manufacturing, and agriculture. So this is just my opinion based on what I read from the news, as well as looking at the trends at the moment, what's happening in our country. Now, we look at information technology and business process management. In 2015, the sector generated US 166 billion globally, and we have this forecast of increasing to 250 billion by 2022. So these are some high value services where we have the engineering services outsourcing to be included. So actually this engineering services outsourcing and some high value services, the India tops. India is getting a huge chunk of the market, and we, the Philippines, are also are one of the leaders in the arena of high value services or business process outsourcing. But it's really important to also consider that since we are engineers, where do we fit in? Now have a look further let's have a look further at the engineering services outsourcing. So engineering services outsourcing refers to outsourcing of work related to the design and development. So this can be drafting and 3D modeling, engineering analysis, product design and testing, design automation, control system engineering, manufacturing engineering, embedded systems, and plant design and process engineering. So basically in the Philippines, we're not at the high level yet. We're still in the entry level. And this report basically is coming from the Department of Trade and Industry in the Philippines. So they commissioned a study, and they're really supporting the engineering services outsourcing industry in our country. So this engineering services outsourcing makes up to almost 55% of the global IT BPM market. So some of the current engineering services outsourcing in the companies are mentioned here. So I won't be mentioning all, but we know that they can be from the US, from the UK, from Europe, from Singapore, Mainhart, and so on. We have also Sorbana, which is also from Singapore. Dyson is from the UK. We have Chiyoda, Japan, of course. Many Japanese companies are also investing. I've heard of a lot of Australian companies also investing in engineering services outsourcing in our country. So let's have a look at the engineering outsourcing industry. This was a report in India, and we see that in engineering design from 2007 to 2011, we see a huge growth from 315 million US dollars to 1 billion US dollars in just 4 years. In engineering service, we are one of the leaders, India and the Philippines. But like I said, in terms of the quality, we're still in the entry level. So this is the complexity of the engineering services outsourcing, or the knowledge process outsourcing in engineering design. So we start from the basic CAD to the modeling, analysis, tool design, to the concept generation and development. So we are basically at the entry level. So what are the challenges to be able to develop the ESO industry in the Philippines? So in my opinion, we need to come up with a better infrastructure, i.e. internet. We need to develop our skills. So aside from what we have learned in our bachelor degree education, we need to develop or learn how to develop simulation models such as finite element models, as well as CFD models. So we should have this mindset that we are not just followers, that we can also be leaders. And we have to have this condition where it is easy to conduct business. So this is the report again that was commissioned by DTI, or the Department of Trade and Industry. This mentioned that the Philippines is still at the entry stage of the ESO complexity spectrum. So we are basically at the CAD 2D drafting, probably some in the simulation, but not too much, I hear. And we probably were in the conceptual design analysis stage. But when it comes to the product's life cycle management and improvement of the quality and so on, we're still not there. So these are the 5 areas that has been identified where the Philippines can further improve on. We have the quality, hard skills, meaning quality of maths and science education, soft skills, English proficiency, and of course, the degree of customer orientation. I believe the degree of customer orientation in the Philippines is high already. The other, of course, we need to increase that talent pool and future readiness, meaning that we should increase the number of scientists and engineers or research engineers. We need to have this quality research institutions, and we should have that availability of specialized training courses that's going to support the engineering services outsourcing industry in the Philippines. So this was also mentioned in the report by DTI. In short term, we should develop we should be benchmarking our skill sets with the world or global leaders. We should develop training centers, and we should upgrade our curriculum. So in the mid to long term, this was recommended: improve the quality of education in the country, focus more on technical and engineering skills, improve quality of math and science education. Second, we need to develop innovation centers. Third, we need to partner with other institutions for R&D and recruitment. So we shouldn't just be partnering internally in the Philippines. We should be partnering with global companies as well as universities too. We don't want to just be growing internally. We should be growing externally. Take note that it's important for us to benchmark where we are. It's not just comparing ourselves with the other companies that are based in the Philippines. So in summary, we discussed a bit of Industry 4.0. So I also discussed briefly the simulation-driven engineering, focusing more on FEA, or finite element analysis, and computational fluid dynamics. I've presented briefly the digital twin, which can be applied to design, operation, and maintenance. And I've also presented the soft skills. So this means that we should focus on developing our skills forever. So we should be lifelong learners. So with this, we probably can define the future of mechanical engineering. In my case, I'll try to define your mechanical engineering. At the moment, probably I see that your generation would be more digital. However, for the future of mechanical engineering, for the succeeding engineers, I hope that you will be able to define that for the future engineers too. So this is my second to the last slide. I'd like to mention that education is still the most powerful weapon which you can use to change the world. This was mentioned by a very famous man who basically changed the world. And also here, also about education. Quality education grants us the ability to fight the war on ignorance and poverty. So to me, I believe that education really has improved my life, changed my life, and I hope that with this presentation, I can also help you change your mindset. So on teamwork and success, there is this African proverb that if you want to go fast, go alone. If you want to go far, go together. Finally, to be able to succeed and to go to where your mission is, you need to surround yourself with those on the same mission as you. So I'd like to thank you for attending this talk, and special thanks to the PSME-UP student unit. Thank you very much. So I stop sharing. Thank you.
Okay. Thank you so much, Dr. Christian Della. Now we're heading to the Q&A portion of the program. Again, for the audience, if you have any questions, simply comment on the live stream with your full name / your school / your question.
All right, so I am now going to read the first question. For the first question by Janko Lee from LPE. Can you tell us about an instances when Can you tell us about instances when design and supposedly innovative solutions aren't able to anticipate user behavior, and tell us how you address it or what you've learned from it?
Well, this probably deals with the old concept of designing that you don't work with your customers early, because if you just design without them being involved, then chances are these are going to happen. So what's going to happen here, if you really want to come up with an innovative solution that's going to address the needs of the users, is to work with them early. So that's my thinking at the moment. Okay.
Another question from Mars Rollier from PESHS. Have you ever had experience when the digital twin had a vastly different output from the actual component? If not, how far is the farthest variance you've seen, and what were the effects?
Well, the digital twin is still in an early stage, but what I can tell you about is the simulation, because digital twin also depends a lot on the simulation models. So we as engineers, we know that we have to estimate things, and the best way forward, if we have a very complicated structure, we need to use simulation models. The difference with the actual test can be huge, sometimes 10 to 20%. And if you have that 20% difference, as engineers, you probably will be happy with that results. Otherwise, if you want to, you can still improve the design, but if it's a huge structures, it's quite difficult to achieve almost 90% similarity. That's from my experience.
Another question from Bebot Lopez from Makati Science High School. Tell us about one of your most cherished project as a mechanical engineer.
Well, as a mechanical engineer, my most cherished project was to lead one of the R&D projects with Vestas Technology R&D. So Vestas is the world's #1 in wind turbine manufacturing. So it's a Danish company. I was able to lead an R&D team to support the development of the world's largest wind turbine blade then. So why do I say this one is important? I mean, not all of our ideas were bought by the company, but here we were able to explore a lot of things, not just technical matters, but also we were able to explore different products, as well as changes or improvements to the incoming products of wind turbine blades. And it's also important to note here that development is not just about you doing all of the work. This one is a team effort, and there are many teams who are also leading different R&D projects to support a single product. Thank you.
Another question from Siegfried Munde from PHS. How do you think your specialization can bring about transformational change and innovation in tackling poverty in the Philippines?
Well, I believe the problem in the Philippines is still employment. At the moment, simulation is still basically new in the Philippines. Of course, we know that we have a lot of 3D modelers in the Philippines, but with simulation, we probably can increase the salary of our engineers there who are performing simulation work for the engineering services outsourcing. The other one is if they decide to go overseas to work. So take note that if we're looking at one engineer, if they can be employed overseas, have a good job, have a good salary, they probably will be helping their whole family. So here, with the increase in their skills that's highly sought after overseas, they probably will be able to get good job overseas. And we probably will be helping a lot of families in the Philippines. Thank you.
Another question from Jeff Betos from MSHS. Pick a particular industry in the field of mechanical engineering and discuss how it can survive during the pandemic and what change it will bring moving forward in a post-pandemic scenario.
Well, there are many industries in mechanical engineering that can survive, but then again, like I said, it's about how we define our mechanical engineering. So in my mechanical engineering, then it's all about gears, it's all about machines, hard machines, heavy machines, and so on. In your mechanical engineering, we're probably looking at digitalization, developing models. And in this case, we see now that during the pandemic, there's now a huge demand for improving the safety in the workplace, ventilation, air conditioning, and so on. So that's probably going to be one of the needs at the moment, create a better working environment for the employees. Of course, with that, safety is also a concern. Once that's already known, then other industries will also follow. Thank you.
Okay, next question from Mikoy Torres from MHS. What are the obstacles that the Philippines currently faces in its approach towards Industry 4.0? Are you taking any steps in addressing those?
Well, yeah, we have heard already the Philippines trying to introduce Industry 4.0 to the people there. But we are still at the initial stage. Well, basically, globally, Industry 4.0 is still at the initial stage, and very much we are at the very, very initial stage. What I can say is, at the moment, we are lacking of skills. We don't really have those skills, even if other people will say we have. I, for one, have the opinion or strong opinion that we don't have, and we need to develop the skills to be able to be successful in using the Industry 4.0 concepts in our country. So what has been mentioned in the study for the engineering services outsourcing based on the study by DTI is we need to improve our, strengthen our knowledge in maths and science, as well as develop more scientists and engineers. This is the way forward to be able to bring Philippines into the era of Industry 4.0. And we also see that the more researchers, scientists we have, the higher the economy of a country will be. And that is already by evidence. So am I taking steps in addressing those? In 2017, I gave talk in one of the regional conferences in PSME. That was in my hometown, held in my hometown in Baguio City. So I gave a talk on simulation. So trying to make the people or make our fellow engineers aware of Industry 4.0. So at the moment, I'm still trying to do that, trying to provide awareness on simulation engineering, which is for us mechanical engineer, is one of those major concepts that we need to focus on. So thank you very much for that.
Another from Apo Samadan from PHS. Discuss what opportunities the field can take in both the pandemic and climate change while setting out a more sustainable path moving forward.
Well, this one probably is a very huge field to answer, but I'll just make it simple. To me, is education. It's really trying to educate our fellow Filipinos to be able to fight that war on ignorance. Well, in the Philippines, we believe in a lot of things. We believe in so many things that if you go outside of the Philippines, they are not basically discussed. But in the Philippines, you give them something like innovation by somebody else, and everybody starts believing, putting them in the press. But basically, when you go outside, these topics are not really discussed because they are so-called away from the reality. So here, pandemic and climate change probably to me is trying to educate the people so that they will be more responsible and be able to address what's going to come. Thank you.
Okay, next question from Ram Bukid from UPD. What local or international problems do you think the younger generation is more equipped to solve with the help of developments in Industry 4.0?
So let me just try to repeat the question. What local or international problems do you think the younger generation is more equipped with the help of development in the Industry 4.0? Well, Industry 4.0 is about trying to integrate the real and virtual world so that there will be a seamless production. So basically, well, to make it simple, it's just improving manufacturing. Industry 1, 2, 3, and 4, basically it's about manufacturing and production. So whatever things that the younger generation can contribute here, like the automation, the robotics, the simulation, and other things that probably can contribute. There's a lot of opportunities here, and I think the talent or the resources are currently available in the Philippines. Thank you.
Another question from Ken from PES. Radical versus incremental change. Briefly explain the difference and discuss which of the two the Philippine ME industry excels at more.
Okay, so let me just have a look at this. Radical versus incremental change. Briefly explain the difference and discuss which of the two the Philippine ME industry excels at more. So let's try to be realistic and be honest. We haven't really seen any huge impact by the Philippine ME industry. We at the moment are followers using technologies that are currently available and mature. So what we probably can contribute to will be the incremental change. So with this one, we can do some incremental change that's going to support our economy. When I say incremental change, let's look at engineering services outsourcing. We have a strong knowledge or foundation in mechanical engineering. We can supplement that with further learning, learning computational tools or computational methods so that we will be able to do more work. I'll give you an example. I have a training center, Principia Engineering, Principia Engineering. So that's my current training center in the Philippines. I gave a training to a person from Cavite, and that was in Baguio. So he traveled from Cavite to Baguio to be able to get that training and simulation. And what he mentioned was there was this, he works in an Australian company, and the Australian company wants to bring simulation in the Philippines. They hired. Unfortunately, there were no people to hire. So eventually, that chunk of work was sent to Malaysia. So if you try to look at this one, these are job lost for the Filipinos. So if we try to improve incrementally, probably we will be able to get those jobs. Similarly with engineering services outsourcing, if we try to upgrade ourselves incrementally, then we probably will be able to get a chunk of that engineering services outsourcing global market, and of course be able to employ a lot of our fellow mechanical engineers. Okay, thank you.
Next question from Margo Hilbay from MCH. What is a concept or development in the industry that you want more students to be focusing on studying or developing?
This is personal. And the reason this one is, I'm saying this one because this is based on my experience. I've been working outside of the Philippines for for about 20 years now. I've worked in top universities, Nanyang Technological University, University of Southampton, UK. So I worked there as a research fellow. I also worked for the University of Newcastle, Australia, and now University of Glasgow. And I've also worked as a research scientist in A-Star, Singapore. And this is based on my experience. I want the students in the Philippines to stop focusing on passing the board exams. Focusing just on passing the board exams is not enough to become an engineer. They should focus more on learning the theory of engineering, because passing the board exams doesn't immediately make you an engineer. You have to understand the theory, because in the industry, you will be applying those theories. You don't have to memorize equations. Equations are available. But unfortunately, because that's one of the requirements in the Philippines, we cannot do much. And that's just my personal opinion, really. Okay, so I hope that question, this one, my answer was very general. So, but of course, I want them to be focusing on all the things that has been put on their table, from engineering mechanics to design to heat transfer. I think they're really important, really. I hope they will include controls. I think dynamics is also included. So that will put us at the level of international standards. I have no question on the quality of students in the Philippines. I know for one, because I was educated in the Philippines, so there is no question about our capability to match the international education quality, that is. Thank you.
Another question from Heinz Kester-Pua from Batangas State University. Does Design for Industry 4.0 supersede other branches of engineering?
I think this one is not superseding, but trying to integrate the other branches of engineering. As you can see, from our side as mechanical, we probably can look at the 3D modeling and the simulation. Others can also look into robotics, and of course sensors and so on, because when we look at, say for example, digital twin, sensors and actuators are important, and that is not superseding electrical electronics engineering. It's basically using the concept, integrating with mechanical engineering. Okay, and we also have computer engineering. So in my opinion, Industry 4.0 is just trying to integrate the different branches of engineering, and of course, business. I mean, yeah. So that's what I can say at the moment.
We have another question from Charles Ilaw from TIP Manila. In 1 to 2 years after, we will be in the industry as a fresh graduate mechanical engineer. Should we focus on mastering a single course to excel in the professional world, or should we divert our skills on all of the majors, like jack of all trades, master of none?
Well, the grass is always greener on the other side. So if you have something that if you like something and you excel in that something, it would be good to focus on that. Remember that everything or a lot of these successful people is about motivation. What do you want to do in your life? If you want to be a jack of all trades, what do you want to do? So probably I think that's a very yeah, I believe that jack of all trades as a strategy is not really going to be successful as a person as a person who really majored on one or two things in his or her life. Yeah, although it's cool, like yeah, you know everything, but yeah, what do you do? What's your impact? What's the impact of your work? You probably will just be following what others have done. But if you have some specialization, you probably will be doing something innovative or coming up with something that can impact your society or our society. Thank you.
Another question from Jasper Neil Paredes from TIPQC. With your experiences and insights throughout the year, which CAD/CAM software has the most power in simulation?
There are many powerful softwares in simulation. I really cannot just mention one. There are many. And basically, this will depend on your customer or the person who needs that simulation model. So in aerospace, there can be Abacus or there can be Nastran. And in some other offshore applications, they probably may like ANSYS. So there are many powerful softwares out there. It's just that they are very expensive. So yes, there are many. I cannot really mention just one. Thank you.
Okay, next question from Paul Peralta from Batangas State University. What programs do you use for making digital twins, and what are the minimum specs like CPU, GPU, and RAM required for running said software?
Yeah, like I said, digital twin is still a new concept. It's still, if you try to look at it in the research stage, planning stage, so it's not really totally 100% implemented. But the value, because they see the value, that's why they're looking into that digital twin. Probably I can answer more in terms of the simulation. Um, I really cannot answer this because this will depend on your application. There are cases in the wind energy. I see some of my colleagues who are working in the computational fluid dynamics to be using very uh, powerful softwares and computers. I don't remember, but they have been running their model for months before they can even get a data. So there are also cases wherein, of course, my case, I run my own code using my laptop. I was working with the wind industry then, and just doing a simple model, I was able to finish my simulation or the computing of my simulation model in 1 week. So again, it can be different for different applications. Yeah, I think here you have to be very specific on the project that you would like to do. Thank you.
Bianca Okbenya from Mapua University asked, how can we ensure that our simulations are accurate enough to work with real-world data? There are cases wherein simulations go very differently in application. How can we prevent this?
Yes, this is the common question. That's why I've heard in the Philippines that some professors there don't want to adopt simulation in their curriculum because they say that it's not accurate. It's far from real world data. But um, you can further improve these results of the model by using standards or best practices that has been already published in there. And there are many cases already where the results of the simulation matches that of the real world. So there are many cases already and evidences to show. It's not to say that they don't match, but Since we know that in engineering, whether we're using analytical solutions, i.e. the formulas that we have, or the simulation models, we're just estimating. And the reason why you use simulation is because the formulas that we have is not sufficient to be able to solve complicated problems. So we have to resort to simulation. And here, if you don't have any test data, it's anybody's ball game. And that is the answer of a famous FE professor in the US before, when I first when I first start attending classes on finite element. As long as there are no experimental data to prove the correctness of your model, it's anybody's ball game. Okay? Thank you.
By the way, a reminder, the evaluation forms are not yet open. Please wait until the end of the program. Okay, so continuing the questions. We have a question from AJ Vitin from CNHS. The question is, in this fast-paced technological world, how can old engineers adapt to the changes and the new problems of the industry? And how can budding engineers improve to tackle these said problems?
Yeah, this is a real problem because I can also tell my experience. I'm not young, of course. I'm getting older. So when I started learning simulation, I had this experience being mixed with the younger generations, and they're really fast to learn, while I was more of, the more difficult students to teach during my time. Okay, and this probably is what I see, what I can see for the old engineers, but it doesn't mean that they should stop learning, because if they really want to do, they still want to be relevant or employed, then everybody has to learn. I'm going to tell the experience here in Singapore, because the Singapore government is spending a lot retraining the professionals, who are, who have been retrenched, so they can learn new skills. And it's probably, I'm not sure what's the situation in the Philippines. I cannot say so. I believe that for older generations, it's not too late to learn. Like I said, everybody has to be a lifelong learner. For the younger engineers, I know you're still young. It's good for you to learn what you can learn. If you go to work, or when you have that first job, focus more on learning, not on the salary. I hope that it won't be an issue. Also for the others, for the younger engineers, if you can stay in school, do your master's degree, please do so. That's my advice at the moment, because the situation at the moment is not favorable. You will be competing with a lot of people. So if you can still stay in school, increase that knowledge of yours, have a few more skills, you're probably better employed after your master's degree. Thank you very much.
Okay, so we have a question from Mikoy Torres from MHS. A lament of many technology-oriented or high-tech solutions that they tend to serve more mundane solutions these days. One Rappler column partially discusses this, unquote, in the constant push to innovate, we steer students away from a deeper understanding of our decades-long problems, and so their innovative solutions are those that address the mundane. It also feeds into a very familiar problem, poor implementation of solutions long known to work. Unquote. How do you address this?
Well, this one is tough. It probably happens because this move is not because they don't want to solve old problems, but because of the new problems. See, every country has this problem on growth and employment. So gone are the times that you can work in the company until you retire. It's not happening anymore. So in this case, um, they have to come up with something, some solutions that can probably address the needs today rather than the needs before. And that is what we see at the moment. So I'm not sure how to really address this question, but what I know at the moment is the solution that we know before 5 years ago may not be effective today. And the problem that's present 5 years ago, even though relevant, may not be the problem that we need to solve today. So yes, there's so many uncertainties at the moment. Thank you.
Another question from Alison B. Kasan from UJPSME MSU main campus. What are the challenges of integrating Industry 4.0 in the degree of mechanical engineering?
Well, the challenges at the moment, what I see in the Philippines, because in Singapore, we are at least trying to implement it slowly. We're going to smart engineering, smart design. I'm the one pushing in our university to push for a simulation strengthened curriculum. So that's possible. The thing here is that we don't have the board exam that's trying to be the barrier. So in the Philippines, we have that barrier, the board exam. So you cannot really improve your curriculum, introduce new changes because the focus is still for many schools, okay, for many schools to have that high percentage of passing. So we see a lot of opportunities being missed because of the current focus of education. So try, for example, if we introduce simulation and then inform the students to be more innovative in their project. The first concern is it going to improve their passing rate in the board exam? So we cannot integrate. So the project, in my opinion, and I'm always okay to be bashed with this one, that the current education in the Philippines, which is board exam based, is addressing an industry back in the 80s. We are not trying to address the needs in the current situation. Just for example, engineering services outsourcing. India, they don't have board exams, but they have a huge chunk of, they have a huge piece of pie of the engineering services outsourcing. They were able to do a lot of simulation models. While in the Philippines, we don't do that. Why? Because we don't have the opportunity to train our graduates on new technologies because of that current barrier that I mentioned. So that, I think, at the moment is the challenge. And I hope well, I don't know who's listening, but if they're listening, I'm always open to be bashed and be challenged. And I'm always open to also give the evidence that the current standardized system of board exam is not doing the Philippines any good. Thank you.
Okay, we have another question from Lars Magpantay from Batangas State University. What do you think is the best contribution of mechanical engineering in Industry 4.0 in the field of A, transportation, B, manufacturing, and C, production?
So contribution in Industry 4.0, to me, industry is still the manufacturing processes. I think it's trying to learn more, being more automated. Yeah, I think we have to mix to be, mechanical is teaching us to be more, more on the heavy industries, more machines, more design, but it doesn't integrate anything electrical. So in our case, we don't really focus too much on the new information like electrical electronics because, like I said, Industry 4.0 is trying to integrate all these engineering disciplines. So probably yes, we are still mechanical engineers, but if we have a bit of knowledge in controls and robotics, then probably we can still improve manufacturing. Transportation, of course, if we know a bit of sensors, actuators, and yeah, a bit of some of this stuff, right? Controls as well. integrate it to our knowledge in machine design, then probably that's good enough. Manufacturing and production probably will be similar, but production sometimes, probably if we're looking at a huge production like oil and gas production, uh, simulation is pretty much used heavily in production, in pipe stress engineering or pipe design engineering, and so on. Yep, that's the answer. That's my answer at the moment.
Again, reminder, the evaluation forms are not yet open for tonight. Please wait until the end of the program. Another question from Blessy Joan Buligan from Ateneo de Davao University. Can you offer tips on dynamic nonlinear simulation using ANSYS as a newbie to simulation in general?
Yes, ANSYS. As a newbie to ANSYS, start first with learning static, structural, or finite elements in static. So from here, you can grow slowly, learn the language, and there's a lot of, after you know the language of using this simulation software, ANSYS, then you probably can go to YouTube University and learn more about this one. But yeah, the challenge here is trying to understand the language being used. So let's start from the simplest one, start with static structural, i.e. Static analysis using finite elements. Okay, thank you.
Next question from Ezekiel Subere from TUP Taguig asks, CFD programs are widely used in different fields of mechanical engineering. What are the pros and cons of CFD software in terms of designing a machine?
Yeah, so CFD is more of fluid flow. So I probably will talk in a general manner. So the pros here is that you will be able to visualize what's going on to your design using fluid analysis, of course, in heating, ventilation, air conditioning. What the current practice is sizing only, doing calculations, determining the equipment or components that you put into that room, but you cannot see how they perform. So that's how CFD can help a lot. Fire protection as well. It's commonly used already. So say for example, in Singapore, you need to have that CFD simulation before they're going to accept that building design of yours, especially when it comes to fire protection and simulation or smoke simulation. So that's one application. The cons for this one is the software is expensive, or the softwares are expensive. But there are some free softwares available that's also capable, but you need to learn. Another cons is, of course, based on our background. I mean, I'm also educated in the Philippines. So this one, you need to invest more in learning, okay, to be able to use this CFD software properly. Like I said, I think it's one of the comment that the simulation may not match reality. So if you're familiar both the theory and the use of the software, you probably can reduce that gap between reality and, of course, the simulation results. So it's pretty much understanding the theory behind this simulation, and of course the limitations as well as the strength. Thank you.
Maria Janina Victoria J. Swanson from Mapua University asked, what simulation program is the best for beginners when it comes to CFD and FEA?
There are many. So in here, I'm an ANSYS user, so I will be more biased towards the ANSYS. There is a free ANSYS for FEA and CFD, free for students they can use. There's also many tutorials. So this Cornell University, a Ivy League university in the US, is implementing finite elements in their mechanical engineering curriculum. There's many free tutorials in Cornell University that's called Sim Cafe. I can also mention about SimScale. SimScale provides free provides free software. I mean, there's some free users or free time to use SimScale. You may want to try them as well. I've also tried Abacus. It's pretty much for the aerospace industry. There's free, but that's a bit more complicated. But yeah, you can try all of these softwares, ANSYS, SimScale, Abacus. I think also SolidWorks will also have this capability of CFD and FEA. So there are many softwares, but like I said, I'm a bit more biased towards ANSYS because I have been using ANSYS for quite some time. But I've also tried the others, and to me, ANSYS is still the software that I prefer. Okay, thank you.
Okay. Next question from Roddy Gobert from ABN. Do you think that ME or your field tends to be dehumanizing in using innovation or innovative technology in dealing with many social issues?
Yes, this can really be a concern because of the focus on coming up with new products. But probably because, I mean, if you try to look at it, the new concepts of designing nowadays, designing with the users, co-creating with the users, design thinking, they're now trying to involve the customers so that whatever issues in the society, they will be able to address. So I'm not sure of any examples that can be, well, I don't really want to say anything about this one, but yeah, I think this can be addressed by trying to work with the users, try to apply the design thinking concept where you empathize with the users as well as try to understand the effects on the society before coming up with a product that's going to benefit everybody. So it's not just the profit, but also we have to ensure that this innovation should also help the society as a whole. Thank you.
Another question raised by Maria Janina Victoria J. Swanson from Mapua University. I'm sorry, I think this is already a repeated
Oh, yes,
question,
yes,
so
it is.
I'll just move on to the other one. Janko Lee from LPE. Any advice or takeaways from engineers, like the problems we should focus on or what watch out for? What other things we should be looking out for beyond concepts and skills in engineering?
My thinking, if you're going to ask me now, what should uh, the young Filipino mechanical engineer should be looking at? Uh, if it's about simulation, the application of simulation on HVAC, FARPRO, and pipe stress engineering. For design, Philippines is not really a country on designing mechanical equipment. Well, I think it's also the same in Singapore. I mean, we don't really have much opportunity there, but it doesn't mean that we cannot apply the things that we learn in design to other fields. But if you're trying to ask me right now, I'm going to focus on the three aspects: the application of simulation on the HVAC, the fire protection, or yeah, the fire analysis, and of course the pipe stress engineering, because that's where the current engineering services outsourcing is moving in the Philippines at the moment. Okay.
Okay. Another question from Nathaniel Mampusti from Mapua University. He asks, as simulation programs are generally heavy on laptops and PCs, what advice would you give students who cannot afford good laptops but are interested in studying simulations?
Well, yes, that's really good to know that you have that interest in learning simulations. I mean, you don't really have to have good laptops. Based on my experience, you can use the old i3, i5s, and you can simply download free softwares that are available. I don't really encourage you using all these other softwares that's not legal. So there are many free softwares like the ANSYS, the Abacus also has, the Simulink has. I'm not sure about SolidWorks, but yeah, these are all good for the just the normal laptops that are available in the Philippines. You don't really need to buy very expensive laptops just to learn them. There should be ways to learn them, and they are just sufficient enough to be used. Yep. Thank you.
Another question from Jerico Baroni from USHS. What gap in the industry locally and globally that we engineers should try to fill in and address? Are there any pervasive problems we should take a shot at?
Well, unless you have the capability in doing innovation, well, my solution here is simple. We have a problem in the Philippines on, this one should be more of, if you try to look at it, the problems that we face are there are many opportunities in the Philippines that we engineers missed. I mean, all this engineering services outsourcing, many would like to invest. Unfortunately, we don't have the skills. Um, in my presentation, I've shown that we have a strong foundation from our engineering materials to our engineering design, heat transfer, and so on. So it's pretty much learning the new technologies. We need to address that thing. CAD, I think the young generations are strong now, but I think when it comes to simulation, you still need to improve those skills. And I think that's one way of getting employed at the moment in one of the engineering services outsourcing in the Philippines. However, if you're keen enough to start your business, you probably may want to learn more about how to become a technopreneur, but that's already out of my scope. Thank you.
Next question from Ray Beth from BSU. As a student, we are often asked how we see ourselves in the future, and most of the answers are always to be a successful mechanical engineer. How can I say that I am successful? How should I measure success in my field?
Contributions. How can you contribute to your company? So the thing here is, if we're just focusing on learning how to use the equations that we have and come up with answers, that's how we are trained. We're basically an Excel tool for them. I mean, input something, we calculate, and so on. But if you can make that Excel and present it to your company, you're probably saving them a lot. So that gives you also the opportunity to find other works to do. Success in my case, how do I define success? I really don't know. To me, I'm just confident enough to apply to a different company, working my way through the different obstacles. And success to me is really defined as the contribution that you make to your company. It's not what you have done that they told you to do, but it's something that they didn't tell you to do, but you did anyway and still make a huge contribution to the company. That's my criteria of success. Okay.
Ken from UPD ask, how can you encourage out of the box thinking in solving engineering problems? Do you encourage it in the first place? Some people have radical ideas that are unfeasible but are good for thought practice.
Well, I still encourage this one because, as you can see, there are many scientists out there. Their ideas may not be applied at the moment, but that also helps others to think more, look at the solution. So the solution that has been presented by the others may not work, but see, that's already a solution that won't work. So something that you won't do. But if that's a solution that may have the potential to work, then that's something that others may try to contribute more or put more ideas on top of that to be able to be successful. So that to me is the development of ideas. Some of the ideas at the moment may not be applicable in the current generation, but because others are just putting ideas on top of that, improving, then it becomes a reality. Yes, definitely there are places for these people, may not be in the engineering, but probably more on the science track, or yeah, academic track. And yeah, there are really people who are really good in this area, and I really appreciate their contribution as an academic. Okay.
Do you have any final thoughts or message to aspiring engineers and entrepreneurs?
Aspiring engineers is, of course, well, you have to be realistic. Passing the board exam is not sufficient. You have to continuously upgrade yourselves. If you can get your higher education, master's at least, while you're still young, then probably you can try to do that. For entrepreneurs, you need huge capital because you have to, if your plan is 2 years, then you have to plan for 5 years. This is something I got when I took this leadership course at the Singapore Management University. So the speaker was from Samsung. So their suggestion is, if you're planning for 2 years, then if you plan to be successful in 2 years, plan for 5 years. So if your budget is just for 2 years, then you probably find ways to get more for that 5 years plan. And then for engineers, to me, is just continuing upgrading your skills and be confident. Be confident. There was this topic on, or something I placed in the follower and the leaders. We Filipinos or Filipino engineers have been trained to be followers, not too much on becoming a leader. So I think this is something that you have to develop as well, that leadership quality in you. So yes, that's what I can say at the moment. Very general indeed.
So we have a one follow-up question. During the practice run, you happened to discuss the Asian problem about how Asian engineers tend to be boxed by problems that are solving or tasked to solve, while Western counterparts have a little more radical approach. Can you elaborate more a bit on this before we go?
Well, let's just have a look at Apple. Where is Apple? Where are the Apple products being designed in the US? Where are they being produced in China? Where are these designs being developed? Probably some Western countries. Where do they further do the designs, do the donkey work? Sorry for that word. They have a lot of engineering services outsourcing in India. So we see that huge gap, but we're also looking at a lot of Asian countries to be evolving. They're now becoming the trendsetters as well. Of course, we have China, we have of course we have still Korea, Singapore. Maybe some innovative ideas are coming out of Singapore, but we see a lot of Asian countries already trying to become leaders in a way. But at the moment, this is one of the problems in Asia. We still do a lot of the heavy work while ideas are coming from the Western country. What I see is more on the education. Okay, so like I said, the board exams. We in the Philippines are trained. I mean, that's my training. I don't know about the others. Maybe it's different now. But my training was to focus on passing the board exams. We were taught to pass the board exams. We were taught that as an engineer, to become an engineer, you have to pass the board exam. So pretty much we're just trying to do whatever was there. But if you try to look at the Western universities, I teach for the University of Glasgow. It's trying to help you analyze, think deeper, rather than just looking at how to apply these formulas and all. It's probably thinking deeper, that should you use that formula in the first place? Or can you just simply come up with an idea, a more simpler equation to be able to solve the problem, rather than following what's being written in the textbook. Can you argue? Can you challenge the formula? In the Philippines, we cannot do that. It's not allowed. In a Western country, they can. So these are quite different from our education. I'm speaking of my current work at the moment, so I cannot talk about the other Western university, but that's how I see how we teach our student is to challenge whatever is there, okay? Which is not, available in the Philippines at the moment.
All
Okay.
right. That's about it for the question and answer. That was an amazing and insightful talk. Thank you for giving us a glimpse of the future with your talk on mechanical design engineering in the age of Industry 4.0. Again, thank you so much, Dr. Christian Delia.
Thank you. Thank you
Now,
very much.
thank you so much. Now, for the awarding of certificates, may we call on Mr. Rampiamonte, the NMESC 2020 co-head.
So thank you again, Sir Delia, for that really amazing talk. I'm pretty sure everyone learned a lot, especially about, actually, no, for me, it's the board exams that stuck a lot with me. So I'm gonna read this out now. So this certificate of appreciation is awarded to Dr. Christian Delia for his talk on mechanical design engineering in the age of Industry 4.0 during the National Mechanical Engineering Students Convergence 2020 Gear Up Restarting Innovation with Mechanical Engineering to Drive a Resilient and Renewed Nation on September 23, 2020.
Thank you.
So that's a wrap for day 3 of the National Mechanical Engineering Student Convergence 2020. We hope you enjoyed and learned a lot from our most esteemed speaker. Stay around for day 4 or drop by in the coming days for more talk. We'll also be announcing the winners of the raffle at the beginning of every show, so don't miss out.
Before you leave, we'll be flashing the details for the evaluation form for the raffle and certificates. I am Jamie Papa.
And I am Saivil Yasis. Thank you, good night, and see you again tomorrow.